Okay, so now in this video we're going to talk about another example. Now in this example we have two sides, right? So we have an exponential on one side, we have a constant on the other side. But look at the constant -2. So in this case here, one, you notice there's no way we can get a common base here because there's nothing we can raise -2 to in order to get a common base of 3. Plus these are both prime numbers, so that's the other thing to keep in mind. We can't do anything with those. They have no common factors, so we're not going to be able to do anything with that. The other thing too is even if we were able to do something, which we'll talk about next, but in this case there's no solution to this, okay? Because notice that, well, we have an exponential here and we've got a constant function over here of -2. But remember, the domain of this function is all real numbers, but the range is what? The range is only positive numbers. Remember, the base also, remember, see this? The base has to be positive, right? And not equal to 1. Okay? So in this case here, this would be an exponential that's above the x-axis, right? Just like all exponentials of this form. Okay? This is just shifted to the left 1 unit. So the asymptote is at y equals 0, right? So if there's an asymptote at y equals 0, this function doesn't go below 0. So it'll never intersect the constant function y equals -2. And so there's no solution to that if you look at the graphs of that as well. Okay? But the main thing algebraically is just to notice that in this case here, there's no real value of x that we can make the equation a true statement. Because any power of a positive number is positive. Okay? So just keep that in mind when you're looking at these. So next video we'll talk about how we can solve equations, exponential equations that we may not be able to get a common base with, but are still, there is a solution. So next we're going to talk about how to use logs to do that. Take care.